Subtopic 3.3 Electric Field. So what is electric field? It is the region or area around a charged particle where any electric charge in the region will experience an electric force. So if we have an electric charge, the electric charge will have electric field around it. If we put a test charge at that area, the test charge will experience an electric force. So how to determine the direction of the electric field? We use electric field lines. And for positive charge, the lines will point outward from the charge. For negative charge, the line point inward towards the charge. This is the example how to sketch the electric field lines. If we have two equal point charge of opposite signs. Equal point charge means the magnitude of each charge are equal. Let's say positive charge 1 coulomb, negative charge also 1 coulomb. Okay, but they have opposite sign, so they will attract. Thus, you can sketch the diagram like this. You can see that the number of electric field lines that goes outward from this positive charge are equal with the number of electric field lines that enters this negative charge. So we know that they are equal in magnitude. Second one, if we have two equal positive charge, here we have positive and also positive charge. They have equal in magnitude. So you can see that the number of electric field lines that goes out from this first positive charge is the same with the number of electric field lines that goes outward from this second positive charge. And since they are repel or repulsive force, there is no electric field lines in the middle between these two. Third diagram, we have two opposite unequal charge. Opposite charge means positive and negative. Unequal means one of the charge has greater magnitude compared to the other one. So you can see that Q1 has more electric field lines compared to Q2. So Q1 has greater magnitude than Q2. Meanwhile, Q1 will be negative sign because you can see the electric field lines goes into it, while Q2 will be positive because the electric field lines goes outward from it. We also have electric field in between two metal plates. For example, we have positive metal plates and negative metal plates. Thus, the electric field lines between these two plates will be directed from positive metal plates to negative metal plates. Example 3.5, sketch the electric field lines for the charge below. So we have positive and negative charge. They have equal in magnitude. Positive Q1 and negative Q2. Let's say this one is 1 coulomb, this one also 1 coulomb. So sketch the electric field lines. 2, 3, 4, 5, 6. And at this negative charge also 6 lines to show that they have the equal in magnitude. For B, we have two positive charge, positive Q and positive 2Q. This shows that, let's say this is Q1, this is Q2. The Q2 has greater in magnitude compared to Q1. So, you can sketch it like this. Based on the number of electric field lines, we can see that Q2 has greater or double the magnitude compared to Q1. For C, we have two negative charge with equal in magnitude, negative Q1 and also negative Q2. Let's say this is negative 1 coulomb, this is also negative 1 coulomb. So to sketch the electric field lines, it will enter into the negative charge. Okay, it's up to you how many number of electric field lines that you want to sketch, as long as magnitude and the attraction and repulsive force are correct. For D, we have positive charge and also negative charge. Q1 equal to 3 coulomb, Q2 is equal to negative 1 coulomb. we can see that Q1 is greater than Q2 and it has triple the magnitude, 3 kali ganda. So for positive charge, 1, 2, 3, 4, 5, 6, 7, 8, 9. So Q1 has triple the magnitude compared to Q2. For electric field strength, we want to measure what is the strength of electric field at certain area. For example, let's take a look at this example. We have sketched the electric field lines. So what about the electric field strength? For example, if I want to find the strength of electric field at this point A for example. So the electric field strength at this point will different compared to electric field strength at this point. The other example is in the middle between these two charges, since they are repelled, so the electric field strength at the center, let's say point C, in between these two charges are 0. Okay, sebab apa? Tak ada langsung electric field lines in the middle between this due to the repulsion force, so the electric field strength in the middle is 0. You can also compare if the electric field strength at point D and also electric field strength at point E. So point D will have greater strength of electric field compared to E because it is near to the charge. Okay, so what is the equation to measure the electric field strength? E equal to F over Q naught. E is the electric field strength. Sometimes we call it as electric field intensity or just electric field. F is the electric force. We use Coulomb's law. F equal to KQ1 Q2 over R square. Q naught is the magnitude of the test charge. What is test charge? Okay, starting from this subtopic, you will see these two terms. The first one is point charge. The symbol is Q. And the second one is test charge. The symbol is Q naught. Okay, point charge is the charge yang menjadi rujukan. Dia dah memang ada dekat dalam kawasan tu dan dia menjadi rujukan. Dia tak bergerak. It just maintain at that place. Point charge, it can be 1, it can be 2, it can be 3. Meanwhile, test charge is the charge that we insert or we put it in the area of electric field produced by the point charge to test dia punya electric field strength, to test dia punya electric force and the others. Okay. You can also compare it with the equation force. Kalau equation force, we use K, Q1, Q2 over R square. We can also use F equal to K, Q, Q naught over R square. So, charge Q1 boleh jadi the point charge. Charge Q2 can be the test charge. So, do not confuse. Sometimes we use Q1, Q2. Sometimes we use Q and Q naught. As long as you understand, point charge Q is the charge that we use as a reference. Meanwhile, test charge Q naught is the charge that we use to test the electric field strength, the electric force and the other values for this concept. By definition, electric field strength E is the electrostatic force per unit charge exerted on the test charge that define the equation right here. Electric field is a vector quantity, so to find the magnitude, just use this equation. If the test charge is negative, do not substitute negative sign into this equation. The unit of electric field strength is Newton per Coulomb because force is in Newton. Test charge is in Coulomb. Direction of E depends on the sign of the isolated point charge. If we want to determine the magnitude, use this equation. But if we want to determine the direction, we need to refer to the sign of point charge. And nanti saya akan tunjukkan contoh dia. No need to substitute sign into this equation because negative sign is only for us to determine the direction for vector quantity. Since Coulomb's law equation is F equal to KQ Q naught over R square, then the equation can be written as E equal to F over Q naught. You can substitute F with KQ Q naught over R square. Ataupun kalau you nak pakai K, Q1, Q2 over R square pun boleh juga. Jadikan Q2 ni sebagai test charge sama dengan Q naught dan you can cancel them out. Equal to KQ over R square. So there are two equations. The first one is E equal to F over Q naught. You can use this equation if you have the test charge. And second one, you can also use E equal to KQ over R square. You can use this equation if you don't have the test charge. you only have the point charge. So Q is the magnitude of the point charge, Q0 is the magnitude of the test charge, R is the distance between the point and the isolated point charge, ataupun R is the distance between the test charge and also isolated point charge. K is the Coulomb constant. So direction of E depends on the sign of point charge only. Direction of F depends on both point charge dan juga test charge Q and also Q0 ataupun Q1 and also Q2. The sign of the charge can be ignored when substituting into the equation. Apa-apa equation yang melibatkan equation vector, so magnitude dia kita gunakan equation, direction dia kita tengok kepada sign. So nanti dalam equation untuk force, untuk electric field strength, do not substitute the negative sign into the equation. Now let's learn how to determine the direction of electric field strength. Assume that we have a test charge Q0 placed in an area of electric field. When we put the test charge, it will experience electrostatic force. So focus on the direction of F and also E. I think that you already know how to determine the direction of force. Kita tengok sama ada it will repel or attract. But to determine the direction of E, we are going to refer to the direction of electric field lines produced by the point charge. For example, we have a positive isolated point charge Q. Isolated means that this positive point charge terasing daripada charge-charge yang lain. This point charge has electric field lines that goes outward from it in all direction, and when we put a test charge, positive test charge in this area, we can see that the direction of F is to the right because these two are going to repel. So force dia akan repel. But for electric field lines, the direction will be directed to the right because the electric field line produced by this point charge is outwards, keluar. So kat sini, dekat test charge ni, dia akan mengalami electric field lines yang ke kanan. If I change the position of test charge, let's say I put the positive test charge right here, thus the electric field strength will go into this direction. If I put the positive test charge at this point, thus the electric field strength will go upwards. That is why the direction of E is depends on the sign of the point charge. Kalau dia positif, dia akan keluar dalam semua arah. Okay, let's try another example. We use the same positive point charge and we put a negative test charge in this area. Thus, kalau untuk force, they are going to attract. So, the direction of force on this test charge will be to the left. But the direction of E will be to the right. Kenapa ke kanan? Because the electric field lines produced by this point charge is going outwards. If I change the position of negative test charge ni, saya letak negative test charge dekat sini. So direction of E will be to the left. If I put the negative test charge at this point, the direction of E will be to this direction. For negative point charge, the direction of electric field lines will go into it. When we put the positive test charge here, the force will be attract. So, direction of force exerted on this test charge will be to the left. Meanwhile, direction of force exerted on this point charge will be to the right. For electric field strength, the direction of electric field strength will be to the left on this test charge because electric field lines around this point charge is going inwards. Okay, kalau saya tukar position, if I put the positive test charge at this point, the direction of E will be to the right. If I put the positive test charge at here, direction of E will be upwards. And the last one, we use the negative point charge and we put a negative test charge here. So, untuk force, they are going to repel. So, force on this test charge will go to the right. Force on this point charge will go to the left. For electric field strength, it will be to the left because the direction of electric field lines produced by this negative point charge is inwards. Okay, So I hope you can differentiate how to determine the direction of F and also direction of E. Direction of F depends on both point charge and also test charge. Meanwhile, direction of E only depends on the sign of the point charge only. Okay, so just now we have one point charge and one test charge. What if we have two or more point charge? So we need to find the resultant electric field strength. For example, we have Q1 positive charge, Q2 negative charge. I know that in your book the signs are different. So please correct it. Q1 will be positive, Q2 will be negative. For this example, we have point A. This is just a point, not a test charge. We have a point A situated at a distance of R1 from Q1, positive charge. And point A also situated at a distance of R2 from negative Q2. So what is the resultant electric field strength at point A? Okay, first, let's label the direction of E at point A due to Q1. Since Q1 is a positive charge and the direction of electric field lines will go outwards from it in all directions, and dekat point A, direction of electric field strength at point A due to charge Q1 will be to the right, ke kanan. Sebab positive charge, dia punya electric field lines keluar. Meanwhile, direction of electric field at point A due to Q2. Q2, direction of electric field lines around it will goes into it inwards. Thus, electric field at point A due to charge 2 will be to the right also. Dua-dua ke kanan. Sebab arah electric field lines tu semua ke sana. Okay, keluar daripada Q1 dan masuk dekat Q2. Okay, there are two electric field strength. So, how to find dia punya resultant? Find the individual. EA1 equal to KQ1 over R square. EA2 is KQ2 over R square. Dan disebabkan dua-duanya ke kanan, so resultantnya tambahkan saja. So the resultant electric field strength at point A equal to EA1 plus EA2. And the direction will be to the right. Okay, for this slide, you also need to do some correction on this diagram. It should be one positive and one negative. So, macam tadi saya tunjuk, find the value of EA1, find the value of EA2, then find the resultant E. Thus, to find the resultant electric field strength, E, when we have two or more point charge, we have three methods. The first method, if E has different direction. Kalau satu E ke kanan, satu E ke kiri, then we can use method 1. Nilai yang besar tolakkan dengan nilai yang kecil. Method 2, we can find the summation of E. If both E are going to the right ataupun dua-dua going to the left, then kita tambahkan sahaja. We know the direction of resultant E. But kalau satu ke kanan, satu ke kiri, so yang kanan positive value, yang kiri negative value. Find the summation of E but consider sign of E. Sama macam konsep force. Okay. Method 3, we can use if direction of E is on different quadrant or it has angle between them. For example, if I have a X and Y axis, EA1 to this direction, EA2 to this direction. Then you can resolve them into X and Y component to find the magnitude and direction. For 3.5 dalam buku, we have 2 point charge Q1 positive 1 coulomb and Q2 negative 4 coulomb situated at a distance of 2 and 3 cm from point A as shown in figure above. Calculate the magnitude and direction of the resultant electric field strength at point A. First, label dahulu direction dia. EA1 will goes to the right. Okay, positive charge keluar. EA2 will also goes to the right because negative charge, the electric field lines into it, dia akan masuk ke dalam dia. So, kita akan ada dua ni lah. To find the magnitude, okay, calculate the value of EA1. Okay, nak pakai equation mana satu ni? E equal to F over Q naught ataupun E equal to KQ over R square. Since we don't have any test charge dekat point A ni, tak ada Q naught. So, kita pakai equation KQ over R square. Okay, we will get 2.25 times 10 to the power of 13 Newton per Coulomb. For EA2, KQ2 over R square, get 4 times 10 to the power of 13 Newton per Coulomb. We need to find the resultant electric field strength at point A ataupun resultant electric field strength is equal to EA1 plus EA2. Okay, 6.25 times 10 to the power of 13 Newton per Coulomb. This is the magnitude. For the direction, you boleh tengoklah based on this diagram yang kita dah sketch, both of these electric field strength are going to the right. Thus, the resultant direction will be to the right also. Equation B. Find the magnitude of electric force that act on a test charge Q3 equal to -4 Coulomb. If the third charge is situated at point A. So what happened is, tadi soalan A tak ada pun test charge. Dia just ada point A sahaja. But now dah ada, kita letakkan negative test charge right here at point A, which is Q3 equal to -4 Coulomb. Since we have the electric field strength at this position, this point A, we can directly use this equation, E equal to F over Q naught. Thus, F equal to Q naught E. Q naught ni adalah test charge 4 Coulomb. E is the electric field strength that point A saja. 0.25 times 10 to the power of 13 Newton per Coulomb. The magnitude of force is 2.5 times 10 to the power of 14 Newton. Example 3.6. We have 2-point charge Q1, which is positive 2 nanocoulomb, Q2 negative 5 nanocoulomb, and we want to find the resultant electric field strength at point C kat sini. Okay, first label dulu arah electric field strength at point C due to Q1 and also due to Q2. Electric field strength at point C due to charge Q1. EC2. We'll find the resultant when x-axis and also y-axis. C1 is situated on the first quadrant, while EC2 will be on the fourth quadrant. There will be angle right here. So the angle at this position is 36.87, and also sama kat sini, 36.87. Okay, I'm not going to share with you how to find the angle sebab you know how to find it. Kalau we get the value of this angle, we are going to resolve field strength into x component and y component. But we need to find the value of this one first. EC1 equal to Q1 over R square. Get 7,200 Newton per Coulomb. EC2. For this one, we got 18,000. Okay, since we need to resolve it into x and y components, so saya buat table. Just need to add this summation of electric field strength on x-axis, summation of electric field strength on y-axis. Tambah 20160, the positive. And on y-axis, -6480. Summation E on x-axis is positive. Meanwhile, summation of E dekat y-axis will be negative. Then the resultant electric field strength will be at quadrant 4 with angle right here. How to find the value of resultant E kat sini? So gunakanlah this equation. We will get 2.12 times 10 to the power of 4 Newton per Coulomb. This is for the angle, kita boleh gunakan tangent inverse y-axis 6480 divide with the x-axis 20160. We'll get 17.82 degrees. For question B, saya buat kat bawah ni. Find the magnitude of electric force that exert on a test charge Q equal to positive 3 nanocoulomb at point C. So kalau tadi dekat point C tak ada apa-apa charge, we put a test charge at point C. What will be the magnitude of the electric force? Then you can use the equation F equal to Q naught E. Q naught is the test charge, which is 3 nanocoulomb, and E is the electric field strength at point C. So yang tadi kita dapat 2.12 times 10 to the power of 4. 0.36 times 10 to the power of negative 5 Newton. C, find the acceleration experienced by the charge in B. Kalau acceleration of test charge, if its mass is 0.5 grams, then we can find the acceleration by using the equation F equal to ma, Newton's second law of motion. F, we already have the force exerted on the test charge, which is from question B. Mass is given, so A equal to force 6.36 times 10 to the power of negative 5 divide with the mass. Okay, 0.5 gram convert into kilogram times 10 to the power of negative 4. Acceleration will be 0.13 meter per second square.